So now this is our very first test. This is our first test with our main fuse, and this is a 125 amp semiconductor fuse. It can actually support around 200 or 300 amps for a good amount of time, but it blows very fast at higher currents. So I'm shutting off our test fuse, and I'm turning on our main fuse. And now we're going to go over to the computer control, and we're going to initialize and pre-charge the inverter, and it does all this automatically. It'll turn on its DC to DC converter. Everything is automatic. And so I'm going to, here we go. Now we're going to pre-charge and contact. So we're running our software, pre-charging, contact is engaged, DC to DC converter PID loop is running and stable. And so now we're running. Before, and we've got our student Moses sitting at the driver's seat in the car. And we're going to go ahead, and I'm going to turn on, and unfortunately this is going to be really loud because it's a noisy pump. I'm going to turn on our coolant pump and fan. And I'm going to give Moses some directions here. So now we're running with ability for high power. Okay, Moses, I want you to step on the gas and just bring it up a little bit. Okay, hold it right there. That's good. Okay, give it a little bit more. Little more. Now start stepping on the brakes. Okay, now let off everything. Okay, now just wait for a second. Now I'm going to go check the motor housing temperature. And this is just a quick test. And it's quite cool. Now we're going to turn on our temperature monitoring software, and we're looking at around 80 degrees on our IGBTs. Okay, Moses, spin up the motor again, and just spin it up, and I'll tell you when to stop. Okay, hold it there. Now give it some brakes. So we're running at around 46 amps. A little more throttle. Hold it right there. 54 amps. A little more brakes. Hold it right there. 60 amps. And let off everything. Okay, so what we did is we took a single sequence pulse. That's our DC link overshoot based on the inductance of our laminar structure, and it's around 40 volts, and we were running at 60 amps. So that's very, very good. These spikes tend to be in the hundreds of volts in typical inverter structures, but we have gotten it extremely low because our structure has an incredibly low inductance. So that's good. We don't even need to use snubber capacitors on our IGBTs. I'm going to do a quick motor temp check, and then we're going to get ready for our test drive. So these are back down to 80 degrees. They went up to 100, but now